Assalamualaikum and hi. So today we are going to solve two questions about thermodynamics. So let us read the question first. A 400% rigid tank contains 5 kg of air at 25 degrees Celsius. Determine the reading on the pressure gauge if the atmospheric pressure is 97 kilopascal. Okay, so from the question we have V equals to 400%, which is equal to 0.4. M equals to 5 kilogram. R equals to 0.0287, and T equals to 25 degrees Celsius. From this information, we can find the pressure of the gauge by using the ideal gas formula, which is PV equals to MRT. So P equals to MRT over V. We're going to put in the information into the equation. M is 5 kg, R equals to 0.0287, and T we need to exchange it into Kelvin, which is 298 Kelvin over 0.4. Okay, if we calculate this, we will get P equals to 1069.1 kilopascal. Okay, so this is not the pressure that we want. So we know that P equals to Pg plus PATM. So PATM is given in the question, which is PATM equals to 97 kilopascal. So from here we can get Pg. So Pg equals to P minus PATM equals to this one, subtract by this one, so we will get 972.1 kilopascal. Okay, this is the solution for the first question. So let's move on to the second question. So the second question says a rigid tank whose volume is unknown is divided into two parts by a partition. One side of the tank contains an ideal gas at 927 degrees Celsius. The other side is evacuated and has a volume twice the size of the part containing the gas. The partition is now removed and the gas expands to fill the entire tank. Heat is now applied to the gas until the pressure is equal to the initial pressure. Determine the temperature of the gas. Okay, so from the question, we know that there is a tank. Okay, and there is a partition here. Sorry. Partition. So we have 1 and 2. So the question said this one is V1, 927 degrees Celsius and ideal gas. And the second one is evacuated, and it has volume twice the first volume, 2V1. And then they remove the partition and then they apply heat on the gas until the pressure is equals to the initial pressure. So the entire tank has 3V1 volume for the entire tank. So from here we can calculate the temperature for the last condition temperature, which is T2 the end temperature. So by using the formula of ideal gas, which is same just like the first question, PV equals to MRT. Okay, if we rearrange this, we going to get T equals to PV over MR. So first is T1 equals to P1 V1 over MR. So for T2 equals to P2 V2 over MR. So the pressure for P2 pressure is the same to pressure 1. So if we rearrange this, and then the volume is 3 times the volume 1 because 2V1 plus V1 is 3V1. So we will get like this. P1 times 3V1 over MR equals to 3 P1 V1 over MR, which means T2 equals to 3 T1 because this is T1. So we already have T1, which is 927 degrees Celsius, so we just times it by 3. So 3 times 927 degrees Celsius equals to 2781 degrees Celsius. Okay, so we can write this in Kelvin, or we can just leave it like that because the question didn't ask to put the end results in Kelvin or degrees Celsius. They didn't mention it, so we can just leave it like this. Or if you you have enough time, then you can exchange it into Kelvin, which is, we change this into Kelvin, we will get 3600 Kelvin. Yeah, just like that. It's just the same. Okay, that's all. Thank you.